I welcome all the participants who have joined this event and then taken an initiative to spare your time with us. So, once again, formally, good evening. I am Mohammad Omar Ali. I'm a member of PLS and NHCE Society. Uh, so, moving on forward with our event, the name of our event is Praudyogeek, and as the topic says, this is based on basic electrical and electronics and Tinkercad software. So let me be clear that I just want to make this event interactive and not just a dull class that everyone attends and then just forgets off just for the sake of certificate. So can I just have good responses from the audiences as well, please? Just give me a heads up that you guys can hear me, okay, from the audiences. You can just go ahead and mute yourself and then just give me a heads up that you can hear me. Anyone from the audience?
Yes, sir.
Yes. So going ahead, I am the co-host of this event today, and with me, Sarthak and my friend Meghna are there to assist me throughout the workshop of this. There are two phases of this event. The first phase is us giving you training, and then you attending a quiz, where this training will be based upon basic electrical and electronics, and then at the end of this session, you will be shared with a quiz link and a feedback form where the quiz link will take you to quizzes.com, and then you will there appear for a quiz that will be assessment for you on the basis of what I have been presenting you throughout this workshop, me and my co-host. And after that, on the basis of the quiz, there will be scrutinizing of participants, and then the results will be soon declared so that who goes into the round two, which is tomorrow. The grand finale will be based on circuit making, and we will be providing you with a question and a frequent amount of time, a specific amount of time that will be considered as whoever finishes the first wins the contest. So I hope I'm clear with all these basic points, and moving ahead with the workshop. So, Sarthak and Meghna, can I have a confirmation from your side? Can I move ahead?
Yeah, sure.
So, as we all know, we have been hearing out this word electricity. What is electricity? Like general idea from anyone, what is electricity? Anyone from the audiences, any person, just a random answer, correct or wrong, it might be no problem, but just a response from you guys. You can also put it up in the chat box as well. Move of the electron, EK says. Nice. Anyone else? It was a fair answer. Flow of electrons, Dhananjay. Yes, fine. So what I will try here to convey the basic positive and negative. Oh, nice. I'm getting responses. Glad to see that. Movement of ions and results of compressing work done, flow of charges. So I believe majority of the audiences are well familiar with the topic of electricity, but to convey it again, address it on those who don't know, electricity is nothing but flow of charges from one place to another through a conductor or maybe a semiconductor. What happens is, as you have all studied in your 11th and 12th grade, the concept of atoms, when the electrons are revolving in a fixed path and then they are at a stable state, when we try to excite them, they go out of their orbit and they are loosely bound. What happens once they are loosely bound is that they tend to move around here and there. Once they do that, once they are out of their stable orbit, they generate a certain amount of energy. That amount of energy, we transfer it and consume it as electricity. So that is one way of saying that electricity is nothing but the flow of charges through the conductor. And another way is also being that as a fact, okay, electricity is a secondary mode of energy. It is not the primary mode of energy. So whenever you see you hear about electricity, it is not there in the nature. We are creating it. We are converting the form from one thing to another, and then we are forming electricity. So this is what the concept of electricity is, and moreover that electricity is a very important and a very evolutionizing key role for our the human race. As we can say, when we had the invention of wheel, they all say that the human race revolutionized from there. In the same way, with the invention of electricity and the invention of bulb by Alva Edison, there have been lot of changes since then. We have revolutionized. We have came to an age where we are sustaining a pandemic and then sitting in our homes, accessing each other throughout without any interruptions. It's been a journey for us. So it is very safe to say that electricity has revolutionized the human beings. So moving ahead, just a second. So why do we need to understand the nature of electricity? We need to understand the nature of electricity because it is a very key and vital role. It is not that understanding about electricity should be the duty of an electrical engineer, not that how electricity works, and then only the electrician in your house or the electrician in your neighborhood should know about it. But as in a general sense, we all should know the nature of electricity and what exactly electricity does. Because first of all, it has its benefits when we consume it in a proper way. But then when we do not know what is electricity and we are not educated about it, it has its own consequences. As you can see, I have put on two graphs as to support my statement that electricity has revolutionized all the industries. You can see there are two graphs based upon the industries that have been shown here. The left one is of India in the past decade or so. We can say that electricity has actually been a very vital role for all our industries. Without electricity, we don't know what could have been our lives. And if you can see, it has been a significant raise in the consumption and the amount of electricity. And then next, moving forward to the right, you have the global chart of the same thing, the per capita kWh kilowatt hour. Kilowatt hour is nothing but again unit of electricity. So moving on further, the next slide. We are now going to understand the basic laws and okay, let me do one thing before we go ahead for the basic laws. We will try to understand what happened with the discovery of electricity. Once our scientists had made different models of atomic structures, and we understood the flow of electrons, there was a very famous scientist called Thomas Alva Edison. I am pretty sure that you all have heard about his story and regarding the the creation and the invention of the bulb. So in the same way, electricity is also a very has a deep history within revolutionizing itself. So there are few laws throughout all the efforts from these scientists who have been there to uh, going ahead to understand the nature of this thing and the phenomena that we have. So there have been a lot of laws, but then for the basic laws, I'll start up with Ohm's law. You know what is Ohm's law? Ohm's law is nothing but that when we the voltage in a conductor, from the voltage or the potential energy in the conductor from the positive side to the negative side, varies according to the flow of the charges in it. You can say that voltage is directly proportional to current E equal to IR also, or else you can relate it to the pie chart that I have put on the right side. And for P denotes power, V denotes voltage, I denotes the current, and R denotes the resistance. So when I talk about Ohm's law, there is a term that has been introduced here, which I have said, resistance. What is resistance? From the term resistance, can I have some answers from the people in the audiences? And what do you think? What is the concept of resistance? Let me know from your side. You can put it in the chat box or unmute and say by yourself. Oppose the flow of current. Nice. Anyone else? Oppose current insulation, opposition, resistance law. Yeah. So the name itself, I'm glad to see the responses. The name itself denotes that it is the opposition of electricity, opposition of the flow of charges. So it resists whenever you try to, push it, try to induce current or try to, energize a conductor. Current flows through it, and then the property that inherent every material has in it determines the nature of it. We have different nature of different materials. We have as we say conductors, insulators, and then between conductors and insulators we have semiconductors. Those don't conduct fully but then don't insulate fully, depends on the voltages they have been operating. So going ahead with resistance, resistance is nothing but the opposition of resistance. Now, when we go towards the basic law of Kirchhoff's voltage law, so there was a guy called Kirchhoff, a scientist. He made two laws. As you know, for physics, we have studied that there have been laws of laws of motions, three laws of motions by Albert Einstein in his theory of relativity. He has introduced us, and then the law of gravity. So like that, we have our own laws of electricity. You can say KVL and KCL. So going ahead with KVL is nothing but that whenever you see a circuit, as in the one I am presenting here in the left picture of my presentation. So KVL is nothing but whenever you see a circuit in a closed loop, given that it should be a closed loop, there are different type of resistors, and we all know that once voltage potential difference across a resistor decreases whenever it continues. So whenever electricity flows into a conductor, the potential decreases from plus to minus. In the same way, whenever we add up all the, we take up a loop in the closed circuit, we add up all the potentials and then we sum it, the sum should be inherently zero. That is the law of voltages given by Kirchhoff. And then in the same way, when we come to KCL, Kirchhoff's current law, it is the same thing, but it is related to nodes. You know what a node is? A node is basically a junction where different connections come and meet. So what happens at a junction is either a current is coming and meeting at that point, either the flow of current is meeting at that point, or the flow of current is going away from that point. Both can be possible at the same time. It might be from two, three or four different wires, or it might be from three independent or two independent wires. If you consider here, you can see I1, I2, and I3 are the three basic, just currents coming on through towards this point that is highlighted in the blue in the between. Let me just take out the laser pointer here. Yeah. So whenever this the in any electrical circuit you see a dot, it basically represents that it is a node. Either whenever you see a node, you should have an idea that there are multiple wires forming over there, either sharing current at the same point. So you see here I1, I2, and I3 are coming inside the node, and I4 and I5 are going outside the node. Now, when we sum it, we don't sum it with the same sign. We take it as those coming inside the node. We take them as positive, and then those going outside the node, we consider them as negative. The same similarity is with this KVL. Pardon me. When we see a loop, and then we see the polarity of the loop here in the KVL. Whenever it starts with positive, we consider this as a clockwise or an anti-clockwise direction according to the flow of the power supply. Now, when we are calculating it in arithmetics, we use plus sign or a minus sign. Whenever we go with the plus sign, it means that the current is flowing towards that device. And then whenever we use minus in KVL, it means that the current is going away from that device. The same thing is happening with the KCL. Try to understand the wider picture here, that when this is only considered in a mathematical form, and this is to calculate the voltages prior to the practical. Okay. Because in practical, you might have your errors, and then you might have your differences. As we all know, there is uncertainty in everything. So kept apart that, we in KCL, I can now, after giving this concept, I can preferably say that all the junctions moving inside a node have equal amount of current that are moving outside the flow. So going ahead with this topic, I hope that this is clear with everyone. These are some basic components of electronics that my friend Meghna is going to continue from here. Meghna, all up to you.
Yes, good evening all. Now I'll be starting up with some basic electronic components. As you can see on the screen, there's a resistor. We all know the resistor, it opposes the flow of current in a conductor. And coming to the very basic components which we all have seen at our homes, electric cell and batteries. So cells, it is the source of electrical energy. So there you can see a definition for the cell. An electric cell is a device that converts chemical energy into electrical energy. So these cells, which are used in our remotes and some movable toys, etc. Now coming to the battery. Your battery is nothing but it is a combination of your cells. So there you can see a definition of your battery. Battery, it is an electrical energy source consisting of two or more electric cells connected together. And batteries are further classified into your primary batteries, secondary batteries, and your primary batteries are those which cannot be rechargeable, whereas the secondary batteries are rechargeable. Some of the examples, we widely use secondary batteries because which are very useful and they are rechargeable. Your phones and in the laptops, whichever batteries are used, those comes into secondary batteries. So examples of secondary batteries will be lithium ion, which is widely used in your phones, and nickel, zinc, etc. Now, you can see there voltmeter and an ammeter. So voltmeter, as the name suggests, it is used to measure the voltage between the two terminals, and it will be connected in parallel to the electronic circuit. And whereas the SI unit of your voltage will be V. And ammeter. Ammeter, it is used to calculate the current across a circuit. It will be connected in series with the circuit, and your SI unit of your current will be amperes. And what is a transducer? So a transducer, it is a sensing element which can convert your physical quantity into electrical signal. Example will be microphone. So microphone, when you speak, so that speaking will be your physical quantity. That will be converted into electrical signal, and further the signals are sent in the form of voice. Yes, next slide. Yeah, now before going into this conductors, insulators, we'll see what is capacitor and inductor. So capacitor, it stores the energy in the form of, it stores the electrical charge in the form of electrical energy. The capacitor, it is constructed in such a way that two metal plates with an insulating medium in between that will be your dielectric medium. And inductor. Inductor, it is used to measure the energy stored in the coil in the form of magnetic field. Now, what is inductance? So, a conductor which opposes the change in electric current will be your inductance. Now, coming to the conductors, insulators, and semiconductor. We are familiar with these conductors, insulators, and semiconductors, right? So, conductors, can anyone put a example for this conductors in the chat box? You can use the chat box. or you can even define conductors, insulators, and semiconductors. Yes.
Yes, we do have responses here. Some say iron, copper.
Yeah. So conductors are the materials which allows the electric charge to flow through them, whereas your insulators will not allow the electric charges to flow through them. And coming examples for your conductors will be iron, copper, aluminium, etc. Whereas your insulators, examples will be your mica, rubber, and wood, etc. And then semiconductors. Semiconductors here, the electric conductivity lies between both conductors as well as your insulators. Example, silicon, germanium, etc. Yeah, next slide. Yeah, now diodes. So diode, it's basically a semiconductor material which allows the current to flow in unidirection. So it will be having two terminals, one is of anode and the other one is cathode. Now starting up with PN junction diode. So PN junction diode is a semiconductor material which consists of P-type and N-type regions within it. And these N-type, P-type will be connected to the battery. If it is connected to the negative terminal, if P-type of the diode is connected to the negative of the battery, it will be reverse biased. When the PN junction diode is reverse biased, the depletion region width will be increased. When your PN junction diode is forward biased, your depletion region width will be decreased. And coming to the LED. So LED is light emitting diode. So what is your LED in the sense? It is a PN junction diode which emits light when it is forward biased. And that is about your LED. You can see the symbol of the LED over there in the screen. And then Zener diode. So Zener diode, it is a special semiconductor device which works only under the reverse biased condition. And you can see the Zener diode symbol on the screen. And coming to the varactor diode, it's on the end of the screen, you can see that. For the varactor diode, you will have a capacitor at the end of the diode. So this capacitor will be variable. You can vary the capacitance value. So this varactor diode, a reverse bias PN junction diode whose capacitance can be varied, that will be a varactor diode. And then photodiode. So photodiode, you can see the symbol of the photodiode at the end of the screen. So photodiode is a reverse bias PN junction whose reverse current will be increased when the junction is exposed to the light. So that will be your photodiode. And so we'll be discussing very few diodes here. And Schottky diode, it is a semiconductor diode it deals with mainly low frequencies and the voltage drop is very less. And it will act as like fast switch. It has a fast switching actions within it. And next slide. So that's all about the diodes. Now gates. So logic gates. So these logic gates are the basic building blocks of our digital systems. So we'll be discussing only 6. There are 7, namely NOT, AND, OR, XOR, NAND, NOR, and XOR. You can note these all. Next slide. Yes, NOT gate. You can see the logic diagram. There's a triangle followed by a bubble. So this NOT gate will have one input terminal and the other one as your output terminal. You can see the truth table. So your A, that part will be your inputs and X will be your output. When your input is 0, that means low. When your input signal is low or 0, your output will be high. And the second condition, when your input is high, that is 1, your output will be low. You can see the Boolean expression for the output. So X is equals to A dash or A bar. You can call it as A bar or A dash. Now, you can see that IC diagram of this NOT gate, which consists of 14 pins And in that 14 pins, this is IC7404. It consists of 14 pins. 7th pin is grounded, and your 14th pin will be your VCC supply. And rest all in this IC, there are like 6 NOT gates inside it. So you can see that pin number 1 has been taken as input to the first NOT gate, and pin number 2 has been taken as output of the first NOT gate. Like that, the further connections are taken out. Yeah, next slide. Coming to the AND gate. So your AND gate, first look at the logic diagram. We'll be discussing only the basics of everything. So the logic diagram, there are 2 inputs with 1 output. Truth table, there are 4 conditions when both the inputs are 0, your output will be 0. And when your one of the input, like if your A is 0 and B is 1, your output will be 0. When your A is 1 and when your B is 0, your output will be 0. When both the inputs are high, that is 1, your output will be 1. To remember this logic, you can read the second line here. If both are 1, that is, if both the inputs to the AND gate are 1, the output will be 1. Otherwise, the output is 0. Now the Boolean expression X is equal to A dot B. And here we have the IC diagram. So it is IC7408 for this AND gate. In the same way, your pin number 7 will be ground pin, and pin number 14 will be your VCC. Rest all will be your inputs and outputs. Next slide. Coming to the OR gate. So an OR gate accepts 2 input signals. Here also the same thing. It will be having 2 inputs with 1 output. But the truth table, it varies. So when for the conditions when both are 0, your output will be 0. When one of the input is 0 and the other one is 1, your output will be 1. And when your input A is 1 and B is 0, your output will be 1. When input A is 1 and B is 1, it will be 1. And your Boolean expression, you can see X is equal to A ORed with B. You can also call it as plus, but it's better to use A ORed with B. So you can, to remember this logic, you can see the second line in the slide. If both are 0, the output is 0. Otherwise, the output is 1. And you can see the IC diagram here. So for the OR gate, your IC number will be IC7432. So there are four OR gates inserted in the IC. You can see pin number 7, same as the previous thing. Pin number 7 will be grounded, and pin number 14 will be your VCC. Rest all pins will be taken as inputs and outputs. Okay, next slide. Now coming to the XOR gate. So XOR gate accepts 2 input signals. You can see the logic diagram first. It has 2 inputs, A and B, with an output X. Now truth table. When both are 0, your output will be 0. When A is 0 and B is 1, your output will be 1. When A is 1 and B is 0, your output will be 1. Whereas when both the inputs are high, if it is 1, your output will be 0. Now the Boolean expression for XOR gate, it will be X is equal to A XORed with B. And you can see, to remember this logic, you can see a second line of the slide. If both are same, that means if the inputs applied to the XOR gate, they are same, your output will be 0. Otherwise, the output will be 1. Now you can see the IC diagram on right side of your screen. So we use IC7486. So the squared is nothing but, instead of saying IC7486, we use this quad 2 input exclusive OR gate. And here, in the same way, your pin number 7 will be taken as a ground terminal, and pin number 14 will be taken as your VCC supply. Yes, next slide. Yes, now coming to NAND gate. So the NAND gate accepts 2 signals. Here you can see first the logic diagram, the AND gate followed by a bubble. So this is your NAND gate logic symbol. It has 2 inputs, A and B, with the output X. Now you can see the truth table. So truth table, it will be completely opposite to the AND gate. So wherever in the AND gate, when the inputs were 1, the output was high. But here it will be opposite. That means when your inputs are same, your output will be 0. Now you can have a look at this truth table. When your inputs are 0, your output is 1. When your input is one of the input is 0 and the other one is 1, the output is 1. And when your A is 1, B is 0, your output is 1. And when both the input terminals are high, that is 1, your output will be 0. Now you can see the Boolean expression over there. It is x is equal to A dot B the whole dash or A dot B the whole bar. Now to remember this logic for the truth table, you can see the second line of the slide. If both are 1, output is 0. Otherwise, the output is 1. Now have a look at the IC. So IC 7400 will be used for your NAND gate. There are 14 pins in the same way. Your pin number 7 will be taken as a ground terminal and pin number 14 will be your VCC supply. VCC supply is nothing but the voltage supplier. And the rest pins will act as your input and output terminals of the gates. Yes, next slide please. Coming to the NOR gate. So here also in the same, this NOR gate will be opposite to the OR gate. So you can see the logic diagram over there. An OR gate followed by the bubble will get your NOR gate. You have two terminals A and B along with the output terminal X. Now the truth table for your NOR gate. So when both your inputs are 0, your output will be 1. When one of the input is 0 and the other one input is 1, your output will be 0. And in the same way, when A is 1 and B is 0, you get output as 0. And when both the inputs are high, your output will be 0. You can see the logic Boolean expression. So X is equal to A ORed with B, the whole dash or whole bar. Now to remember this truth table logic, you can take down the second line of the slide. So if both are 0, your output will be high, that is 1. Otherwise, the output is 0. Now you can see here the NAND gate IC diagram. In the same way, here also the pin number 7 is taken as ground and pin number 14 is taken as VCC supply. Next slide. Now integrated circuits. So integrated circuits, now we all discussed, like previously we discussed that ICs, right? Each IC is like IC 7400, IC 7432, IC 7486. So like that, these ICs are, it is a like set of electronic circuits on a small chip or a small layout. So this is your IC which we saw in the previous slides. So for each gate we'll be using different types of IC numbers. That's all.
I take it from here.
Yes.
So, yeah.
Thank you.
So, as we are continuing upon the point of ICs, I would rather like to add a point upon here. ICs are basically those components that have actually revolutionized our electronics industry. You know, where in those olden times we had our computers, if you've realized, those computer sizes were big because the transistors used in them were cathode tube transistors. You didn't have compact sizes for them, you needed big equipment to operate them. But through the revolution of technology, we are being able to integrate more than a million and billion nowadays, the 9 mm and 5 nanometer and 9 nanometer, all those specifications of chips and the compactness and the small sizeness of those chips are incredible. Billions of transistor in just 9 nanometers of a microchip. That is incredible actually. So what the integrated circuits are, but nothing but different devices integrated into one semiconductor block that is closed into a shielded thermal and electrically insulated enclosure that has different output pins. Now there are ICs are everywhere around you. If you take your phone, till your washing machine, till anything you take around you as considered to be a watch as well, you see all ICs around. So ICs do play as a major part of the society nowadays, the electrical society, and it has been a phenomenal basic building block for it. Now, moving on ahead with the topic, I would like to address upon the point, what is a transistor? Now, transistors can be in rough words, I'll say that transistors are amplifying and switching devices. Now, when say amplifying, what do we amplify here? Switching, what do we switch here? Why do we need a transistor for switching? We can use a switch. But the way these transistor works as a switch is very different rather than as a traditional switch. In a traditional switch, you have to put a physical presence over there and then turn it off or turn it on. Whereas in compared to a transistor, these can be controlled either by current or by voltage. Now, coming on to the current and voltage, these are again divided into two categories, but I'll address it upon later on. Whereas now we'll just consider this bipolar junction transistor to this is nothing but a semiconductor device, and all these type of transistors do exist in your computer. The computer or the mobile that you are currently using contain these kind of transistors. This is a 3-terminal device. Now, where we study it as a single device, you see you have 3 terminals. Now, the name of those terminals do speak for itself. There is a base, that is a P type. Okay, coming around to the part as a NPN type also, I just forgot to address this part. What is an NPN type? When you see a semiconductor block or a transistor, these are different types of materials doped into it. The structure of an atom, if you see a molecule of silicon or germanium, it has different atomic numbers. It has a specific number of bipolar coordinates, and if I go into the core chemistry of it, it has different kind of bonds. What we do here is whenever we are making a semiconductor block, forming it with a vision that we are going to make it a transistor, we do dope it. What is doping now? Doping is nothing but then they just add different materials or different molecules of other materials into one material, such as if you consider now, why do we do that? You see those NPN. The P state you see in the between is heavily dense with holes, or we say positive material over there, which is highly as an acceptor of electrons. And if you go into the N part, which is on the emitter and collector side, this has to be the same for both the sides, because this is basically a path for traveling of the electricity. Once the current goes into the emitter, it comes out from the collector. Now, where the switching part comes is from the base. Now, the base has to be the opposite of what emitter and collector material is to be. This is saying logically, because once you say that you're controlling or switching something here, you need to have a resistance stop over there. Now, this base acts as a gate for it. The door of a classroom where people enter, and then once after the class has commenced, you close the door. This is something like that. Now, going into the graph that you have on the right side here, we have some characteristics. Keeping on the track of characteristics when you're studying electronics is very important. When we come on to a graph, you see on the on the horizontal axis you have your volts, and on the vertical axis you have your current. Why do we compare voltage and current? Because these are the only two quantities that drastically change or show their characteristics once you have powered the BJT and then you're using it. When we go towards the positive junction, I'll just make an example here. If you look down at the GIF that I have included here, the graphic picture in the bottom left, you'll see that there is a battery, there is another battery, and then there are some kinds of connection made to the N side and to the P side as well. Now, the between part is your P side. This yellow part is your N side. Consider. If you see the polarities, I won't get into the polarities part, because again, that will be much confusing for you. And as of the basic standpoint of view from our vision for this event, we don't actually require it much. but later on I'll sure address it once it has to be done in the MOSFET part. So what happens is, generally think of that, okay, there is a flow of electrons from the emitter side to the controller side, or depends on the application how it goes. So from the in some applications we can flow it through collector to the emitter. Now what happens here is, when you are basically, a BJT is a current control device. If you increase the current on the P side, it will resist the flow of current and through the N side. So what happens is, you don't get the same amount of current that had to be collected from the emitter side. Now what happens, this results as in the stopping, or the switching of the circuit here. The signal drops or the signal increases. Sorry. Yeah. So when we are continuing onto the graph, you can see that there are two types of regions here: the forward bias of this PN junction diode and the reverse bias. When we go to the forward bias, when we are applying it, there are two points called breakout points: the forward breakout point, the reverse breakout. What happens here, once the semiconductor crosses this breakout point, it is activated its switching position. Either it is on from there, either it is off from there. You go on the forward side, you apply a voltage of 0.1 to 0.9 volts, and then you don't see much difference, a drastic difference in the current. But once you are crossed with your 0.9 volts mark, the current suddenly shoots up. This is where your breakout point is here. And then when you go in the reverse part, this is simply just changing the polarity of your circuit and reversing the flow of electrons, or the reversing the flow of current path for it. You can see that when you're going to -1 and then till -5 volts, also there is no difference here. There is a huge difference when you compare this forward and negative bias. But then those are again for different purposes, that you can see in the forward breakout point, and then you can see it in the reverse breakout point. Now I'll go ahead with the MOSFET part here. This is also a transistor, and there are different kind of transistors. As we have seen, one was BJT. Now I'll compare some similarities and some differences between them. These are again the same amplifying and switching devices. That also does a switching job. This also does a switching job. Now I'll come into the part of the differences between them. First of all, the basic difference between them is that BJT is a current control device, whereas metal oxide field effect transistor, the MOSFET, it is a voltage control device. You don't need to rely on the current. The current remains constant here, whereas there the current wasn't constant. You were heavily dependent upon the current. When we are talking about the terminals of this device, this also is a tri-terminal device, and naming of the terminals is also done according to what functions they operate as. If you see here, there is gate, drain, and source. Gate again is almost similar to what the job of base is in the BJT, whereas in the part of drain and source, again the same thing, but here the source is where the current is coming from, and then the drain is where the current is leaving towards. Now remember that these transistors are low current devices and they are low voltage devices. They are heavily nowadays the use of metal oxide field effect transistors are in the chips of your phones, and mainly, as you see in the animation that I've put over there, it is mainly into the VLSI design of a CPU, the central processing unit. Now what is VLSI? VLSI is again the study of these the integration of these circuits on a very small level. That is what VLSI does throughout the branch. It is a very diversified branch. Now when you come to the construction of it, There we had doped it and then put as a sandwich for the p upon n and then again p upon it, or n upon p and then again p upon it. That kind of architecture is there for a BJT, whereas in an MOSFET you don't have that. You have either an n channel MOSFET or a p channel MOSFET. No, what is the major difference between n channel p channel MOSFET is there, that in an n channel MOSFET you are using it, the N channel is as the majority part of the MOSFET. It consists the majority, the material of the MOSFET, whereas the P channel is the majority in the P channel MOSFET, positive. Now, as an example, if I take for a general, if you see LED circuits in your house, you have LED lights, right? I'll just address upon the small example of the LED lights. There are LED drivers for those LED lights. Some LEDs are dimming, some LEDs are not dimming. Let's come upon the dimming LED part. Okay. Now, what happens is if I take an LED, take an N-channel MOSFET over there and connect it. Now, how will I connect it? I connect a microcontroller with it, and then what that microcontroller is, you don't have to bother about it, because it will just switch the amount of voltage flowing to it into the gate. Whereas now we are connecting the LED with the power source and then making taking the source of the power through the source terminal of this N-channel MOSFET, and the output will be the drain for which the LED is going to be connected with the positive terminal. And then the negative terminal will again going to be into the battery. I'll show this example once we are going into the Tinkercad, these kind of examples. Now what happens is the microcontroller will give us pulse towards this gate, either 1 or 0. If you know the digital binary thing in electronics, there is either 1 or 0 state of any kind of switching device. So what happens is, say 1 volt is our switching threshold here, and then we apply 1 volt towards the gate. The current that is flowing through this LED that is coming from the power source will stop, and then as soon as you add a you withdraw that 1 volts or the 1 from the gate and make it 0 volts, again the current starts to move. This is how high switching is done, basically. This is how the microcontroller does as for the high switching. There are different kind of techniques for modulation as we go. Most famous is PWM, that is used in LED driver circuit innovation, where LED drivers are basically be using on basis of PWM is a different kind of modulation technique, where you will just vary the width of the modulation of the voltage, and then the certain desired level of output of the LED will come out. Now, moving ahead, we also have one more kind of transistor, that is the IGBT, but that is called an insulated gate transistor, that we won't focus much upon. I'll transfer my part to Sarthak, where he'll address you on the last and the final remaining topics of this presentation. Then we'll go ahead with the thinking. Sarthak, over to you.
Yeah, good evening everyone. Now we will talk about some of the most common electric devices. One of them is relay. Now, relay is an electrically operated switch that opens and closes the circuits by receiving the signals. Now, number of devices can vary from single to multiple. One of the advantages of this relay is you can close multiple devices at a single time. Okay, now you can see on the left, that is the circuit of relay where you have the necessary connections. Now, one of the most common terms which everyone will come across when studying about relay is the NC and NO part. The NC part is the normally closed contact, while the NO part is normally open contact. Now, if I give you a simple example of how a relay is used, consider your TV remote. When we press the main on button of our remote, the TV automatically switches on, and vice versa. Now let us talk about types of relays. Now, based on contacts, based on physicality, it is of two types. One is your movable contacts and one is your non-movable contacts. Movable contacts is also called as mechanical relay, where the we can use magnetic force to switch off or switch on the relay. And as Oma mentioned about MOSFETs again, that is another type of relay, that is the non-movable contacts, where instead of doing a physical contact, we can use semiconductors or electrical elements to switch off the relay. Yeah, Oma, next slide. Okay, let's talk about transformers. Transformers are the electrical power transmission devices that is commonly used to increase or decrease the supply voltage, based on which we call them as step down or step up. If we plan to increase the voltage, we call it as step up voltage, step up transformer. If we plan to decrease the voltage at the secondary winding, we call it as step down transformer. Now on the right side, you can see the structure of a transformer, in which the left part is your primary windings and the right part is your secondary windings. Now this transformers works on the principle of, just a minute. Yeah, this transformer works on the principle of Faraday's law of electromagnetic induction and mutual induction. Now how this works is, whenever a flux is produced in the primary sides, it also take affects the secondary terminal. And overall, a transformer carries many operations. One is, as I said earlier, it's transfer of electrical energy from one circuit to another, transfer of electrical power from one circuit to another, and without changing the frequency, we transfer the power through this. Now, yeah, Omar, you can go to the next slide. Now, electrical motors. It is one of those electrical appliances which converts from electrical energy to mechanical energy. Now, how it has happened is, we use the power stored or the energy stored directly or indirectly. This we use to operate the machines. Now, based on this, the electrical motors are of two types. First is based on the source, that is your AC motor and DC motor. Further, your AC motor is divided into synchronous motor and asynchronous motor, which is your induction motor. Similarly, your DC motor is divided into self-excited and separately excited. Now, further, if we differentiate, it will go into the series motor, shunt motor, based on where we put the flux. Yeah, Uma, you can add on something if you want.
Yes, Arthur, going ahead with this, I think this suffices. If anyone has any questions with the end of this part, can tell before we start the Tinkercad part. Anyone from the audiences have any doubts? Anything that you wanted to be addressed before?
You can put in the chat box.
Or just unmuting the message. So yeah, I think there are no doubts here. The participants are very much clear because I didn't see any messages popping up here. So we'll do one thing now. I will start presenting the Tinkercad part where we all have been waiting here. So now going on to the second part of this workshop. Mm, if you have seen in the poster, you mentioned about the Tinkercad. Tinkercad is nothing but where we all simulate these kind of circuits and use and operate with those elements that I have already told you about. So now the final round of this event will be conducted based upon Tinkercad. There, where you will be given a circuit to design. So we'll go with the simulator now. You can just go onto the Google and search for Tinkercad, Tinkercad, and then you will get a website called tinkercad.com where you have to log in first, and then you can, just a second. Yeah. So I'll log out first, and then I'll go to the home of this so that you guys know how to log in. So in order to create a circuit here, you just need to sign up with or join now with any of your Google accounts, and then it will take you to your home page where you can just go ahead and wait for this page to appear. Now here in this part, if you see on the left of your dashboard, you will see a circuits part. Now go on to the circuits part and then go for create a new circuit. Till here, I hope it is clear for everyone, right? Can I get responses from the audiences that it is clear till here?
You can type in the chat
Yeah,
box.
yes. They have sent.
Yeah.
Now, with respect to what tomorrow we are going to do is we are going to give you a circuit design. Whoever qualifies in the first round will be called tomorrow for the grand finale. Now, what this grand finale is going to be upon is basically what you have studied today, and then the actual application of what you are going to apply it in circuits. Now, if we take upon a basic circuit, we'll just take, uh, if you see on your right side, you will have this part where you can select components. Now, for an example, I'll take a resistor. See a resistor, you have different kinds of resistor. This is a potentiometer, that is a varying resistor, but we won't think that will be considered. But for an example, we'll take the resistor, drag and drop it here. This is how you use a resistor over here. Now, the value of resistor might be in different kinds of ranges. It might be in kilo ohms, ohms, or in different kinds of, units. So I'll consider this as to be a 100 ohm resistor. Let's name it as R1. Let it be over there. And what else can I show you over here? Okay, you can take let me just keep it over here, keep it aside, and then we'll go ahead with another one. Take an LED for an example. See, you can grab up an LED here and then fix an LED with this one. There are the two terminals of an LED, that is the anode and then the cathode. The right one, which is the longer one, and the cross one is the anode, and then the shorter one is your cathode over there. And there are different kinds of LEDs available here as well. And as goes for the components that we have shown you throughout the presentation, please can you repeat the process once? Okay, people want me to repeat the process once again, so I will repeat it once again. Let me just complete this circuit. Yeah, so once we are what the components that we have shown you over there in our PPT are all available here to be used. Now, tomorrow's circuit will basically mostly be upon what those basic devices have been told to you. Now, as we are running out of time, and I'll just show you this quick example of the small circuit that is already being built here as an example of the Tinkercad. There is an LED that is connected from an anode towards the resistor. And then there is a power source with positive connected to the resistor and then negative connected to the cathode of the LED. Now, how to simulate this? If you see here upon your right side, you have start simulation. Once you feel like you have closed the circuit and the circuit is proper, you can go ahead with starting the simulation, and then seeing that the LED glows here. If you see, if I stop the simulation, the LED turns off, and then when I start the simulation, the simulation runs and the LED turns on. Now, this is a basic kind of simulation that I have been showing you here. Tomorrow, there will be a logical based question asked upon this to solve a basic logical circuit. So coming on to the part of connecting the circuit, you can just grab upon a resistor here and make it like 1 kilo ohms, fine for now. And taking a LED, again, taking this LED, connecting it like this, keeping it upon the terminals will let you to connect it, and then taking a battery, coin cell, 3-volt battery will be enough to just lighten up the LED. Now, how to connect this circuit? If you go here, you will see the wire type. Now, we don't need to use any different kind of wire types, as we are just using the normal type. If you click on this, the normal type of wire, you'll get it. Take from one terminal of this coin, click it over here. You will see this automatically, a wire will be appearing here. Now, how to join it? Just click on the other terminal of the next component and just click it over there. This is how your wire is joined. Now, as of to the negative terminal, I'll take it over here, keep it over there, and then again press it over here so that it stays down and turns. And then again coming over here back to this, taking it like this, and then just clicking with your left click. It is as simple as that. When you start up the simulation, the LED glows. Stop the simulation, the LED turns off. Simple as that. So I hope this is clear with everyone. Can I have a response from the chat box? From the participants, please let me know that it is clear with you people. Okay, clear. It's clear. So now coming to the conclusion part of it, we are done with this. Now we have concluded the teaching part of our event. Now you in the chat box, you will be shared with two links, that is the feedback link and the quiz link. Please be sure that you join the quiz link, start the quiz, see the time limitation in the quiz, that will be around whoever completes it first qualifies to the next round. So try to solve the quiz as soon as possible. It will be just a multiple choice question quiz, and then you just have 15 questions over there onto your multiple choice tab. And then once you solve those 15 questions, you can go ahead with the feedback link. Further people who will qualify into the next round will be intimated onto their email IDs shortly.